We'll solve some more numerical on per unit calculation. The statement of the numerical: there is a 100 MVA transformer with a 33 kilovolts with a reactance of 15%, which is connected to 3 motors having the capacity of 30 MVA, 20 MVA and 50 MVA, and operating at 30 kilovolts with a 20% reactance with a subtangent reactance of 20%. These motors are connected to a transmission line with 50% 50 ohm reactance. Then motors connected through transmission line and 2 transformer having the capacity of 100 MVA, 32 kilovolts at delta side and 110 kilovolts star side with a leakage reactance of 8%. This is how the circuit looks like. That is a generator which is connected to 3 motors here, 1, 2, 3 motors through a transmission line here, and the 2 transformer here. Okay, the first step in solving the numerical is that you have to specify the rating of each and every component in the power system. This is generator has got 100 MVA 33 kilowatt with 15%, that you have to specify. In all the equipment specification, they are specified here. It is 100 MVA 33 kilowatts 15%, and 3 motors are 30, 20 and 50. It is 30, 20 and 50, and operating at 30 kilowatts. It is a 30 kilowatts with a reactance of 20%, therefore it is a 20% is written here. And 2 transformer, they have a capacity of 110 MVA, therefore I am written 110 MVA, 110 MVA with a leakage reactance of 8%, here 8%. The next step is to decide the rating of the winding which is connected towards the generator side, and the voltage capacity of the winding of the transformer which is connected towards the transmission line. How much voltage you have to choose? That is, one is 32 kilowatts, one winding, another winding is 110. Therefore, then you look into the capacity of the generator. If you look into the capacity of the generator, it is 33 kilowatts. It is a 33 kilowatts. Therefore, better to have 32 kilowatts towards the generator side. Ultimately, this is a transmission line. It is operating at high voltage. Therefore, at that side you have to take it as 110. Therefore, what you have to do? Here you have to choose 32 kilowatts. Here you have to choose as 110 kilowatts. When it comes to this particular transformer, then it is already connected to 110 kilowatts. Therefore, this winding is also should be connected to 110. Means that towards the transmission line side you have to connect 110, and towards the motor side, if you look into the motor side, the voltage is 30 kilowatts. Therefore, in that case you have to connect 32 kilowatts as the voltage towards that motor side. Okay. Therefore, I am specifying here the rating of the transformer: 32 kilowatts, 110 kilowatts here, and 110 kilowatts this side, that is the transmission line side, and 32 kilowatts towards the motor side. This is how you have to choose the voltage rating of the transformer on either side of the transformer. Okay, this transformer, and everything is specified here. Then the next step in the solving the problem is that what is given is select the generator. That is, you can look into the statement here, that is, select the generator rating as the base quantity in the generator circuit. Means you have to choose the more generator rating itself as a base quantity in this generator circuit. That is a choosing the base, because he is given in the statement select the generator rating as the base quantity in the generator circuit. Therefore, I am choosing the rating of the generator as a base quantity in the generator circuit itself. That is delta star I mentioned here. Then you can look into that is the base quantity. What I am choosing is 100 MVA 33 kilovolts. Then what are the base quantity in the transmission line side? What are the base quantity in the motor side? You have to check, because we have got there is a transformer here, because the base voltage will change to the 50 ohm side. Further, there is one more transformer is here, therefore the base voltage will be changed. However, the base MVA remains the same in all parts of the circuit. Therefore, here is also it is 100 MVA, 100 MVA. Here is also 100 MVA. I will solve that problem. Just you can look into here. Okay, that is the next step is to make it the base MVA here. What is the base MVA here? It is also 100 MVA. MVA is remains same. Here is also 100 MVA. Then next step is this 33 kilovolts base should be transferred to this side. This should be transferred through this particular transformer. This you have to transfer through this transmission. Therefore, what is the ratio here? It is 110 divided by 32. That is 110 divided by 32 into 33. You have to work out that is the base kilovolts you are getting here. Okay, you are getting the value of, I will tell you, that is 113.43. That is 113.43 kilovolts is the base quantity you are getting in the transmission line side, that is in this circuit. And here also 100 MVA, this 113.43 should be transferred to the motor side through this particular transformer. Therefore, it should be 32 divided by 110 multiplied by 113.43. In this case, you are getting the voltage of 33 kilovolts. You are getting the voltage of 33 kilovolts. Means here you are getting base value of 33 kilovolts. This is how you have to calculate the base quantity in three parts of the power system. This is one part, because it is dividing by this particular transformer, and this is the second part. You are having this base quantities, and this is the third, and these are the base quantity here, and these are new quantity. These are new quantity. This is new for the transmission line. This is new quantities for the motor side. Okay, next, once we know the base quantity, and these are the all old quantities. These are old quantities. These are old quantities. Then you have to apply the formula, and you have to find out the per unit, the reactance of each component of the power system. Okay, that will work out now. Okay. Now I have what? I given the statement here. The base MVA is same for all sections of the power system. Means this 100 MVA remains same for all sections of the power system, base MVA. And the voltage you can calculate at this point. I demonstrated already. Once again I am doing here calculation. The base voltage in the transmission line is 110 divided by 32 multiplied by this 33. That is what we are getting is 113.43 is the base voltage in this circuit. Base voltage in this circuit. And similarly, the base voltage of 113 in this should be transferred to the motor side through 32 by 110. That is 32 by 110 into 113.43. What you are getting is 33 kV. Therefore, I am mentioning here all the base quantity 100 MVA 113.43, and here 100 MVA 33 kilovolts. This is how you have to. The first step is mention all the specification of the component in the power system, and you have to choose the proper voltage rating of the transformer on the generator side and the transmission line side, and the transmission line side and the motor side. Next, you have to specify the given quantity of the base in that particular circuit. That is given generator rating as a base quantity in the generator circuit. Therefore, I am choosing this. Then once I know the base MVA, that is remains same for all parts of the circuit that I mentioned everywhere. However, because of the transformer, the base kilovolts will change from circuit to circuit because of the transformer in between. That were calculated. Here 33 kilovolts, here it is 130.43, here it is 33 kilovolts. Okay. Once we know all the base quantity, and these are the old quantity, these are the new quantity. Okay. Then you have to use our standard formula. Z per unit new is equal to kV old square by kV new whole square MVAN by MVA old into Z per unit old. Now you are getting the Z per unit new. You have to apply for each component in the power system. Therefore, first I am taking the generator here, generator. Then the old quantities are 100 MVA 33 15%. New quantities are 100 MVA 33 kilovolts, 100 MVA 33 kilovolts. Then you have to substitute this quantity in this particular equation, this equation. Then we are getting Z per unit new is equal to kV old. kV old is 33, kV new is 33 whole square. MVA new is 100 MVA, MVA old is also 100 MVA into old. X per unit is 15%, therefore I am taking 0.15, therefore it remains the same, that is 0.15 per unit. J.1 per unit is the generator per unit, new value of per unit value of generator. Then I am going for the transformer 1. In the last problem I told you, if you are calculating the per unit reactance of the transformer, whether refer to the generator side or refer to the transmission line side, it is the remains same. If you are considering the generator side, in that case, the new values are this. These are the new values. Whereas these are becomes the new values for calculating the new per unit value. It is a new value for the transformer. For this side, if you are towards the generator side, you are taking your old voltage is 32 kilovolts. The base quantities are this, and the original value or old value is 32. Instead of, if you are choosing the transmission line side, in that case you have to choose these are the new quantity. These are the new quantity, and the old voltage you have to take as 110 kilovolts. Okay, that you have to remember, and you have to do the calculation accordingly very carefully. Okay, now I am doing the calculation for the transformer 1. Okay, I am considering generator side. In that case, the new values are this: 100 MVA 33, 100 MVA 33 kilovolts. Then the quantities are 110 MVA 8% and 32 kilovolts. It is 32 kilovolts because we are considering generator side, and therefore I am choosing this as a new base quantity. Therefore, old quantities are 110 MVA 32 kilovolts, that is 32 kilovolts 8%. New quantities are 100 MVA 33 kilovolts. Then you can substitute once again in this particular equation, that is Z per unit new. What I am getting is 0.06838. Similarly, you have to calculate for the transformer 2. Before moving to the transformer 2, then you have to find out Z per unit of the transmission line. Here in the transmission line is given the actual value. Then how to find out the per unit quantity? the per unit quantity, if the actual value is given, Z per unit can be calculated by ZA divided by ZB. ZA divided by ZB. ZA is 50 ohm he is given. Therefore, you have to find out ZB from the given quantity using the formula KVB square divided by MVAB. So that we will get the ZB, and ZA by ZB, that gives the per unit value of the transmission line. That we will calculate now. That is transmission line. The new quantities are 100 MVA, 113.43. That is, it is given here. Okay. Therefore, Z base value, that is KVB square, MVAB is the standard equation you have derived already. Then KVB is 113, MVAB for transmission line is 100. Therefore, what you are getting is 128.66 ohm is the base quantity. Therefore, Z per unit you are defined as ZA divided by ZB. ZA is 50, and ZB is already calculated as 128. Then what I am getting is for the transmission line is 0.3886 per unit is the per unit reactance of the transmission line. Then we will move to the transformer T2. The transformer T2. Here once again I am considering towards the motor side. Motor side. If you are considering the motor side, my base quantity will be this, because I am considering towards motor side, and my old voltage is 32. That you have to look into. Therefore, old quantities are 110 as it is. Voltage is 32 kilovolts. Voltage is 32 and percentage reactance is 8%. Whereas new base quantities are 100 MVA, 33 kilovolts. Then once again you can substitute the Z per unit new, that is 33 by 32 divided, that is 32 is the old, 33 is the new whole square, into 100 by 110. Then you are getting 0.06838 is the per unit value of the transmission line. Transformer 2. Okay. Then comes to the motor side. Then for all the three motors you have to calculate. Once again you are using the same formula here. Just motor. First I am taking new quantities for all the three motors is 100 MVA, 33 kilovolts. Then I will consider motor 1, that is the first motor. Its old capacity is 30 MVA, 30 kilovolts, 20%. The same thing I am written here. For that, I am calculating the Z per unit. What I am getting is 0.5509. What I am getting. Similarly, go for M2. The old quantities are 20 MVA, 30 kilovolts, and 20%. Substitute in the equation. Once again, I am getting the value is 0.8263. Then you will calculate for M3 with the old quantities are, these are the old quantities. Then you find out Z per unit, what I am getting is 33.05. This is how you have to calculate the per unit reactance of all the equipment. From that you have to draw the equivalent circuit diagram, reactance diagram. This is a basic diagram. To draw the reactance diagram, first you have to draw the base. Then generator, it is a remote end, it is start from ground. All these three motors also at the remote end, these also started from this ground. Just you look into here. Generator started from ground, and you mark bus number 1 and 2. From generator it is connected to the transformer 1, then to transmission line, then it is connected to T2, then it is connected to bus number 2, and three motors are connected here and they are connected to ground. This is the first motor, second motor, and third motor. Then you have to specify the new values of the reactance value you are calculated using the formula. These are the values, new per unit value on a common base. This is how we have to draw the reactance diagram for the given network.